Okay, so let's go over how we can transform graph of an exponential functions like g of x equals b to the power x using shifts, reflections, and stretchers. So we'll look at each type of transformation and how it affects the graph. So first, let's talk about vertical shifts. So if you have a function with g of x equals b to the power x plus k, that means this shift moves the graph up or down. So if your k is a positive value, then the graph shifts up. If your k is negative value, it shifts down. But remember, in this shift, the shape stays same and it just moves vertically. Okay, so now let's talk about horizontal shifts. So if you have a function g of x equals b to the power h minus x, so that means this moves the graph left or right. If your h value is greater than 1, it shifts right by h units. If your h value is less than 0, it shifts left by absolute value of h units. Okay, so now let's talk about reflections across the x-axis. So if your function is of the form negative b to the power x, so this flips the graph upside down across the x-axis. So here all y values becomes negative. Next, reflections across the y-axis. So if you have the function as b to the power negative x, so this flips the graph left to right across the y-axis. So the exponential growth becomes decays or vice versa. Okay, next, vertical stretches and compression. So if you have the function as a multiplied by b to the power x, then if your absolute value of a is greater than 1, the graph stretched vertically. So it gets steeper. But if your a, absolute value of a is in between 0 and 1, it compressed vertically. It looks flatter. Next, let's talk about horizontal stretcher and compression. So let's say your exponential function is the form b to the power a multiplied by x. So if your a, the absolute value of a is greater than 1, the graph is compressed horizontally and it grows faster. But if your a is in between 0 and 1, it stretches horizontally and it grows more slowly. So in summary, shifts moves graph without changing its shape, but reflections flip the graphs over an axis. So stretches and compressions change how steep and wide the graph look like. So just by adjusting the parts of an exponential function, you can create variety of transformations. So we'll explore some of these in the next examples. Okay, so let's analyze how different transformations affect the exponential function y1 equals 3 to the power x. So we'll look at 6 variations of this function and describe what each one does to this graph y equals 3 to the power x. So first of all, let's sketch y1. So we already know it's an exponential growth. So let me sketch that function. So here, let's say this represents y1. So here I have taken x-axis as the asymptote and it goes through the y-intercept 1 and it increases with x values. Now let's take the second function. y2 equals 3 to the power x plus 4. Okay, so here you have x plus 4 as the exponent, which means this is a horizontal shift. Horizontal shift. And next we have to decide whether this shift is left or right. So since this is plus 4, this is going to be a left shift by 4 units. So here you have to remember adding inside the exponent, move the graph to the left. So what you can do is you can move the same graph to the left by 4 units. So what I'm going to do is I'm going to copy this. I'm trying to copy this and then I'm going to move exact graph to the left by 4 units. So here, if you consider this point, this should move 4 units to the left. So this is 1, from here to here just 2, 3, 4. So that means that point should move somewhere here. So let me take my graph and then I'm going to move 4 units to the left. So if you move this to the left, this is going to be something like this. It's not exact, but it will be something like this. So y2 is something like this. 3 to the power x plus 4. So now let's talk about y3. Y3 is 5 multiplied by 3 to the power x. So here this is a vertical stretch. This is a vertical stretch. And the graph stretches vertically by a factor 5. So that means it rises faster and appears steeper than the original. So this is the original one. So y3 rises much faster and it appears steeper than the original function. So let me sketch that. So it will be something like this. Something like this. So this purple color represents y3. Okay, now let's take another color for y4. Okay, so y4 is 3x plus 3. So this is a vertical shift. And next we have to determine whether it's going to move up or down. Since this is a positive value, this shift will be upward by 3 units. So that means this entire function, the original function or parent function, will move upward by 3 units. So here what you can do is I'm gonna if you move this 3 units up, it will be something like this. Okay, this is not good. It will be something like this. So here I just took the same shape and I moved this 4 units upward. So here, if you consider this point, the y value is 1. So if you move that by 3 units to the up, it will relocate at 4. So this pink color graph represents y4. Okay, so next we have y5. So y5 is 3 to the power negative x. So 3 to the power negative x means it's a reflection across the y-axis. So this is a reflection across y-axis. And here the input x has negative sign, so the graph is flipped left to right. So instead of growing as x increases, now it decays. So if you sketch this function, so now you have to take the reflection across the y-axis. So this line will represent y5. So this is the original one. So you took the reflection across y-axis. So now it is like this. So this will represent y5. Next, let's move into y6. Which color? Okay, I'm going to use orange for y6. So y6 is negative 3 to the power x. So here, this is again a reflection, but across x-axis. So this is a reflection across x-axis. So the graph is flipped upside down. So instead of rising, now it falls below the x-axis as x increases. So now it's gonna be something like this. So this is your y6. So here the y-intercept is -1. y7 is 3 to the power x -4 plus 5. So this is a combination of two transformations. So here x -4 will shift the original graph to the right by 4 units. So let me write that. So x -4 will shift the graph to the right by 4 units, and here you have plus 5. So plus 5 will shift the graph 5 units upward. So plus 5 is a vertical shift. It's a shift upward by 5 units. So if you sketch this graph, okay, I don't think I have enough space because this is 4 and this line will represent 5. So the graph will look like this. So use your calculator to sketch this. So here your horizontal asymptote will be y equals 5, and it is shifted more towards uh, right by 4 units. So in summary, all these functions are based on y equals 3 to the power x, but with shifts, the shifts can be either left, right, up, or down, and also stretches, compressions, reflections. So all these transformations change the graph position, direction, or steepness, but the exponential nature of the curve remains same.